to solid modelling, to showing off joints and assemblies, perhaps some sculpting, and we really want to see a level of detail there that shows off your skill sets to future employers. We've been talking a lot about creativity in this module, and we want you to approach your problem-solving tasks in a creative manner. And with each of the different assignments that we're setting on the module, we're always trying to, I guess, add opportunities for you to demonstrate your creativity in different ways. And so for this particular assignment, we're asking you to create a poster as well. So you'll be creating an A3 sized poster that shows off your redesign of the Mars rover. And right at the end, we'll invite you to a Q&A session where you get to show off some of your work, and Ben and I will ask some questions about your respective designs. So last year, that was a really nice ending to the module. It was a nice opportunity to see all of your hard work. And it was really the culmination of weeks of the different tasks that we set you. And seeing that through your submissions was really a wonderful thing for us to be able to assess. We're asking you to complete your CAD assembly and submit that as a single zip file. So one of the things that we are also on top of in this assignment is your file management. And the reason for that is it's something that really trips groups up, and we can go on past experiences. We can tell you this on good authority that it seems to be one of those really silly, obvious things that you think, well, I'll just create a zip file and it's all done. I'll submit that on the VLE. But we've encountered various issues along the past 2 years where we've run this project. So as you start to develop different files, as you export your CAD data, what's really important is that you think about your file structures, the naming of your components, making sure that everything is complete when you submit it, because believe it or not, we often do get assembly files where the parts are missing. And that's one of the key things with submitting your CAD data, is that your assembly file is just one part of a package of files that you're going to need to submit. So we'll explore this in future weeks, of course, but exporting your data, naming it clearly, and making it just easy on us as your markers really goes a long way as well as part of this submission. And we really want to see some creativity, folks. We're going to give some advice on the next page of the brief. But remember, any engineer can solve an engineering problem. It's when you can solve engineering problems in a creative way that you really start to create things that show a real element of resourcefulness. You know, you show a level of detail and thinking that's far more mature than the majority of submissions, and we want you all to stand out. So we want to see lots of creativity, lots of sketching, lots of ideas, lots of prototyping, and we want to see that you've covered the scope and the breadth of the problem that we're challenging you with. So over the weeks, there'll be opportunities for you to discuss your design plans with us as well. So that's something that we look forward to. In terms of the benchmarking class, obviously always aim for the highest. We want to see projects that show an excellent level of detail. And I tend to come back to this, I guess, anecdotal story several times. And it's the story about there was a tutor of mine at Brunel University who taught Jonathan Ive, the Apple iPhone and iPod designer. And as a group, there was a small group of us on the masters. We asked the lecturer, so did Jonathan Ive stand out? What made him stand out? And the lecturer, it's always stuck with me. He said it was just the level of detail he went into. In an early project, he was asked to design a pen, and the level of detail that Jonathan Ive went into in designing that pen far superseded that of his peers. And I guess that kind of is the type of mentality and approach that you should be thinking about. Is you want to show that your solution, the innovations in your suspension, have got the underlying engineering theories there, but also just that level of detail where you've included things like an analysis of the forces, perhaps an analysis of the different vibrations, cost benefit considerations. You know, that's a really big issue, because what we're really suggesting there is you might find 5 different ways of solving a particular sub problem. And at that point, it's that algorithm almost in your mind of the benefits of features versus costs versus complexity versus simplicity. And we want to see that all of those things have been considered as part of your solution. And we want to see that your poster gets the thinking and the ideas that you've generated across. Your big final showpiece should be shown off through this poster, and through your CAD work and through the prototypes that you develop as part of your process. So always aim for that extra level. You always want to stand out with the work that you're producing, folks. And this showpiece piece of work, it's weighted at 40% of the module, so it's pretty serious. If you take this seriously, if you put in all of the level of thinking that I guess people like Jonathan Ive have put into alternative projects, that's the kind of level of quality that we're expecting. So here we're giving you some suggestions. So in terms of some starting points, in a moment we'll visit the JPL website together. We're asking you to start by just simply understanding the existing JPL rover. So have a play with the toggles on the website. Download the CAD data, import it into Fusion, assemble it if it needs assembling. Start to get a real feel for the existing rover. We want to see lots of building as part of your thinking process. So sketching is fantastic. It's a natural thing that you will be doing as part of your process, but sketching can take you so far and CAD can take you so far. We'd love to see a little bit of problem solving that involves making, you know, testing some of your suspension designs, using some household materials, seeing if you can get some of the springiness that you might think you might get from a sketch or from a CAD model. Does it actually work in real life? So we'd love to see you documenting that through photos, perhaps videos, and maybe some experiments as well. So if you're unsure of how something might possibly work, experiment, and you can take photos or videos of those experiments and show those off as well. We want you to think carefully about scale. So there will be parts of your final prototype where you're going to be needing fastenings, so perhaps nuts, bolts, etc. If you simply scale down, you will find that those nuts, bolts may potentially become very odd numbers. So, you know, you don't want to specify nuts and bolts that are 1.3 millimeters in diameter. Although we can get those, it's much better if we find something a bit more standard. So, you know, your M4s, your M5s, your M6, etc. So it's not just a case of scaling everything down. It's a mix of scaling down, but also being a little bit pragmatic and thinking of yourself as the builder of this prototype. What can make things easier for you? Remember that if there are 100 screws, there are probably 100 nuts on the opposite end that need to be fastened against. You can overcome that through some very clever design. So maybe some push fit fittings, using the natural springiness of plastic to ensure that some pegs can pop into holes and then not pop out. You're reducing the weight in doing that. You're reducing the number of parts in doing that. And you're making your design easier to assemble, easier to build. So think very carefully about those finer details. We want you to make the most of your design skills. So this is a great CAD exercise. We want everybody in the group to contribute to that. And that's one of the benefits of Fusion 360, is that it does allow teams to work collaboratively together on the virtual model. So it's not limited to the best CAD user in the group. We want you all to contribute to the CAD models. So set yourselves up a project, share that project with one another, start building together. It is possible to build in real time. There are, from my experiences, delays in doing that sometimes, but it is possible. So that's just one of the many great functionalities of Fusion 360, is the ability to work collaboratively. We don't want you to lose any functionality. So this is something that's happened in the past, where we've ended up with some suspension systems on prototypes on the CAD models from past submissions, where actually we've lost maneuverability. So you've got this great initial benchmark that can move in 360 degrees almost, and it becomes a very rigid suspension system that can only move forwards and backwards, and that's the kind of thing that we want to avoid. So think very carefully as you're developing your designs that you're not reducing any of the existing functions of the Mars rover from the JPL site. We'd advise you to consider using modular design. There are benefits to using modular designs in terms of your group work. So it could be that you have a team leader for each module who's in charge of particular parts of that sub-assembly. It helps to spread the workload. It also allows you to test parts of your vehicles independently, without having a huge impact on the rest of the development of the project. So one of the things that we consider is starting to think about what those big overarching modules could be. You know, just pen and paper, what are those big modules? And perhaps then start thinking about which ones you could combine. So you end up with maybe 4 overall modules, and so you've got a team leader for each one of those as part of your design process. We've seen some great posters over the years. We've also seen some very poor posters over the years. So in a moment, we'll give you some information that may guide you in terms of poster design. We really want it to be visually engaging. So summarize what you've done. We want it to be concise. We don't want to see reams and reams of text, but we want to see something that's visually interesting. And there are smart cues that you can use in poster design to elicit interest from a viewer. And that's what we want to see, is we want to see you guys become part-time graphic designers almost as part of this assignment, and demonstrate what you've created through a really nice poster. And there are various free software packages that you can use to create your posters. And I guess one of the most easy to access is just from the suite of Microsoft Office products. So while some of you may have different desktop publishing software experience, things like PowerPoint or Microsoft Word, even Microsoft Publisher, those are free to access as students, and they do a great job. So there's great examples of PowerPoint posters, tutorial type videos on YouTube that I've seen in the past, and it's amazing that you can get that vector graphics type software ability using something as simple and easy to use as PowerPoint. So we're not expecting you to use sophisticated graphics type software packages in the slightest. Use what's at your fingertips, and as always throughout the whole process, we're going to be on hand to give you some pointers, suggestions and hints and tips. And finally, revisit the lecture notes. We have covered a lot of information that's going to help you. So go back to some of the creativity lectures, for example, and morphological charts. You know, that's a great method for you to maybe start thinking about alternatives for improving your suspension designs. That's just one example. There's going to be future lectures where the notes are going to help you as well. So we'll give you a lecture on the different suspension designs. So again, those hopefully are going to help you with the development of your projects. In terms of the learning outcomes, folks, this is an assignment that really does tick a lot of boxes with the IMechE. So without reading these word by word, remember that all of the learning outcomes on your modules throughout your degree program fundamentally come from the Engineering Council and in turn through the IMechE. And so these are learning outcomes that you need to be able to demonstrate at the end of your graduation. And so there's lots of things here that we're ticking off with this one piece of work. So we're asking you to evaluate outcomes and formulate solutions to engineering problems that you are defining. Working within constraints. So as you start to work through the project, you'll start to understand what those constraints are, and you work within them. You start to acknowledge your responsibilities as engineers. You'll start to develop a detailed spec of your designs as well through this project, and you'll be demonstrating different design methods. Of course, you'll be creating great 3D CAD content. You'll also hopefully be using CAD as a way to evaluate some of your ideas. So perhaps some of the simulation features in Fusion could be used to help guide your decision making. It's always great if you can include 2D drawings as well. So as part of your submission, you might want to think about, in addition to your CAD models, perhaps there's some additional data from your CAD that you could not only produce for this assignment, but just practice different techniques in CAD and potentially be part of that really strong portfolio piece that you show off at the end of this. You're going to be synthesizing a prototype, developing a prototype, and that's using everyday objects at home. We're not asking you to be cutting out chunks of aluminium, etc., but we want to see that you can think in 3D as well as in 2D, and the ability to communicate your ideas through different channels, whether it's the poster, whether it's through your CAD, whether it's through prototyping. You're essentially communicating your ideas through different media. And of course, working in teams, being able to coordinate, manage the team. That's all really important. So you're developing all of those skill sets further. And so on a final note, this is your marking scheme. So study your marking scheme carefully. Start thinking of your timeline from this week till the end of the project, right at the end of week 13, and allocate percentages of time to each of these tasks according to the weighting. So it's really important that you understand the weighting, and obviously the elements that have the largest weighting is where we're expecting a little bit of the additional detail, folks. So make sure you cover the considerations for each of the different marking criteria, whether it's the prototype or the CAD model, or the ability to show us that you're using data to influence your design decisions, right through to your poster and model of your redesign. Just again, going through past experiences, folks, this is probably the criteria that we've found in the past has been a little bit skimmed on by past students. And it's really that BEng part of your degree, this is where we really want to see that you've done some calculations or you've performed some kind of analysis, and that you're able to interpret the numbers from those analyses, that you're able to use some of the results from the software to really guide your decision making. So whether that's through a little bit of FEA, some simulation, some pen and paper calculations, etc. We really want to see a lot more of that through this submission as well. And again, it's great stuff for you to be able to show off at interviews, that not only have you got this great poster, prototype, etc., but here are some of the calcs that are behind the scenes that we've considered as part of our solution. These are some of the simulations that we've performed behind the scenes as part of our final solution. Yeah. So before I start to actually, I'll just check if there are any questions at this point on the chat, and then I'll start just going through a few of the resources that we've put up on the website for you on the VLE. So let's just switch to the chat and see how we're doing. And Ben, is there anything I may have missed there in the intro?
No, that was fantastic. There's just one thing while you were talking. I just thought sometimes it can be useful just to see the kind of thing that you're headed towards in the end. So I'm just going to share my screen for 20 seconds to show, just so people know, roughly what an output might look like. This was a good result, a good example from last year. So I hope maybe you can see that now. This is one of the posters. We're about to talk a bit about poster design, so you can see whether you think it matches up with the principles of poster design we're about to talk about. But, this is the kind of level of CAD, and there's some building in the bottom right. I don't want to leave this up for too long, because I don't want people to start getting fixated on one idea rather than any others. But that's what we want to see, is a model being built, a fusion model being shown and how it works in engineering, and then something that brings the whole thing together and makes it into an exciting story. That's all I wanted to add.
That's very timely. Thanks, Ben. I'd completely forgotten that we had examples. So yeah, thank you for sharing that. Very timely. Thank you. Carl, just before I move on to some of the resources, are there any questions that are pressing? Okie doke. So there's a question from Rahul about making a prototype. So it's a really good question, Rahul. We're not expecting really high quality material, chunks of metal type prototypes. It's more things that are a bit more accessible to you at home. So from last year, again, we're going on what students did last year. There were a variety of different materials that they used, from drinks cans to toilet rolls to cereal boxes, to plastic sheets, to card. There was one group that, incidentally, they developed spherical wheels as part of their, I've given you an idea there. Let's go with it. Spherical wheels as part of a solution. And they ended up sourcing very small apples, which sounds insane, but as part of their tires, they had these small apples on their prototype. It does sound insane, but it really worked because it got the point across. So yeah, the idea is using things that you've got to hand.
Maybe I can just share my screen again, because I've just dug out a really nice example of prototyping and building from last year that I'd forgotten all about. This was what someone built. I think if you were being critical, you could say maybe that's more of an aesthetic model. These pipe cleaner springs might not work exactly as the spring dampers they're substituting for, but it's the kind of model that tells you a whole lot about how you're going to need to fit things together in the end. So, you know, that kind of thing is maybe a target to aim for.
So George is asking, will the prototypes be constructed on campus? Possibly. We're going to proceed with the assumption that it's going to be from home. So you'll be making your prototypes from home. Following Easter, there may be the possibility of having some on-campus sessions. So should we be in that situation, George, then yes, it opens up the possibility of us using workshops, etc. There's a question from Emma about the prototype suspension. Ben, I'm not sure if you're typing out a response or. Sorry, Ben, you're on mute.
Yeah, I am indeed typing out a response. Let me finish typing it and then we can talk anyway. I'm just closing it up.
Sure.
No I think the answer is the prototype can do lots of things. Put it in terms of the assessment in the answer I've just typed up. That, you know, we'll give marks for something that looks really interesting and exciting and captures people's attention. We'll give marks for a prototype that really shows how the suspension is going to work. We'll give marks for a prototype that shows us what the thinking is behind your CAD. So there's no one kind of, you must do this prototype. And in fact, you know, one of the things that I think we're both saying is we were surprised and delighted last year by all the different things that people use their prototypes to do. So don't let us limit you in how you think about your prototype. Is that a reasonable way of putting it, Alessio?
Yeah, absolutely. Yeah, absolutely, Ben. Yeah. Folks, I'll come back to questions momentarily. I'm just going to guide you through some of the things that we've put up on the VLE to help you. So first of all, let me just refresh that. You'll find the coursework brief. The next topic down, you'll find the link to JPL's website, and once you click on that, you'll be taken to something that looks a bit like this, and it's quite fun to have a bit of a play. But if you use the arrows on your keyboard, you can actually start to maneuver the on-screen Mars rover that you see, and you just start to get a bit of I guess some observational studies going in your own minds. So just by observing those black bars that you see on the sides of the vehicle that's on screen, you start to get a bit of a feel for the suspension system that's on the JPL model. So while it's very good, it's not perfect, of course, so it can be improved. And eventually we're going to guide you towards clicking on the Get Started option up here at the top. So once you click on Get Started, if you want to find out about some of the specific details on this particular design that you see on screen, you'll find that you can actually start to click on various parts of it. So wherever you see one of these dots, there's some information. There's like a drop-down window that will pop up that will just give you a little bit more information on each of those components or sub-assemblies. So the ones to read about specifically, well, all of them are very important, but there's one on the rocker bogie suspension system. But start to really analyze those comments as just an initial nice and easy bit of research for you to all carry out. So you've got things like the differential pivot, and there's some nice animations there to help explain what's going on. And the rocker bogie suspension system, which if I just spin this around, hopefully I can get to it from there. So it's just useful to start to get a feel for the different subcomponents of this particular vehicle. In terms of the CAD data, which is a great starting point as well, I've got to remind myself where that is. So I believe if we click on Get Started again, what we want to do is click on See the Plans, and it will take you to another website, and you will find, if you click on Mechanical, there's a series of folders. If you click on Mechanical, there are different assemblies here for the model that was on screen a few moments ago. So if we click on one of these, so let's click on the body assembly, you'll find that in each one of those assemblies there is a CAD folder. So opening that CAD folder, there's a variety of different formats. Fusion will open all of those. If you wanted some advice on which one, step files are something that I generally like to use. They tend to remember some of the color data. So if the original engineer added colors to different parts, step files tend to maintain those. Having said that, SolidWorks files and IGES files, they will open up equally as easily in Fusion 360. So any of those formats is fine. You don't need all three of them. So just one of those will open up in Fusion, and then you've got that particular part of the model in Fusion. So one of the first tasks for you to do is potentially you can just start to download all of those CAD files. So after you've downloaded the body assembly, you might want to then download the wheel assembly, rocker bogie, the head assembly, etc., etc. And each one of those folders, always look for the CAD folder. And in the CAD folder again, look for the step file or the IGES or SolidWorks, doesn't really matter. Okay. And that's all there on this GitHub website for you to download for free. So you should be able to construct your own versions of this design here. So that's a really good starting point to start to get a feel for range of movements, what some of the key sub-assemblies are called, what do they do, and just really start to understand some of the underlying engineering behind it. Now we've put a couple of links here to help you just do a little bit of background reading on some of the Mars rovers from the past. So if you want to read up on a little bit of history of Opportunity, that's one of the Mars rovers that sadly is no longer moving. There's a web article that provides some information on what happened there. So by starting to understand why two of the Mars rovers managed to get onto Mars, which is no easy feat, but then are no longer moving and no longer able to send information back. That's a really good starting point for you folks as engineers to start to diagnose perhaps a couple of the problems you might want your designs to overcome. So what caused those two Mars rovers to get stuck on Mars? And what can you do as engineers to stop your Mars rover getting stuck on Mars? So there's a couple of articles there. There's the spec to the tyres. So if you need a reminder of some of those dimensions, these were the tyres that in the past we gave to students as part of their prototype. So you might want to model those potentially, or scale down the existing Mars rover to about that sort of diameter. But the wheels is something that you might want to consider as part of your redesign. emphasis on parts. So it shouldn't just be redesigning the wheels, but it could be part of a series of improvements that you suggest. There's a short video there, which I'm not going to play just yet, but it's a short video just to really set the tone that there's different countries who are now starting to send things to Mars. So in addition to China, the UAE, the US, Japan have now entered this as well through Toyota. So there's a little video there that will take you to a YouTube video, and it just explains a little bit about Toyota and Japan's plans to get a Mars rover over to Mars in 2029. And I thought I put a link there to poster. Oh, there we go. Yep. There's some advice on poster design, which I'm just going to run through now. So clicking on that link, it will take you to some advice that's been put together by the University of Birmingham. And we thought that this was really good guidance. It's very clear. And these are some things for you to consider as part of your poster design. So first of all, we've specified the size. So we specified that your poster is going to be A3. And that's a really important thing, because then that starts to guide the next decisions about things like text size. You know, you want your poster text to be readable. You also don't want the text to be huge. So you can only start to really make some of those decisions once you know what format you're working on, whether it's A3 or A2 or A1. So we're not talking about huge posters that are A1 or A0. We're talking about A3. And as such, we want you to think about every part of that space for part of your poster. That's not to say that every single millimeter of the area should be covered, but start to think about things like, you know, where your heading is going to go, where your student names are going to go, perhaps the name of your design if you want to name it. Are you going to have one key image with other images around it? Are you going to line up the images on one side? You know, you can start to have a think about the layout on the A3 sheet. It's really important that you sit down as a group and assess what you're trying to achieve through your poster. So you don't want to get every single consideration that you've made on the poster. You kind of want a summary, a snapshot, if you will. Of course, you want to cover the key features. Of course you do. But some of those key features might have, you know, possibly 10 different FEA models that you may have tested in Fusion, perhaps. And so showing every single bit of detail on your poster is going to fill up that space really super quickly. And so it's important that you sit down in your group and just start to plan what you're trying to achieve in your poster. So what are the most important things? What are the 10 headlines that you want to include? And that's a great way of approaching this, is kind of thinking of 10 key messages you want to get across. And then start thinking about whether a couple of those could be combined. So ideally you want to maybe end up with 6 to 8 key messages, and then allocating space to each one of those key messages. There's some suggestions here over the content. So this is guidance. It's not us prescribing this, but give your poster a title. Think of perhaps a summary, a short introduction. Aims and objectives are probably one of those things that we won't need for this particular poster, but it could be something that you might want to include. Certainly for your final year, you'll be developing aims and objectives for your final year projects. So it could be a nice opportunity for you to, in your groups, discuss what the key aims and a few of the objectives are for this particular challenge, just to help you guys focus. What is important is to show a little bit of your methodology, so different things that you've done, summary of any results, and in your discussion and conclusions, really that's your final design. you really want to show some of the key design features that show some of those details. Being selective over the information you present is important. So that comes back hopefully to some of those key headlines. So thinking of what those 10 key messages are that you might want to get across on your poster, narrowing those down to maybe 6 to 8, and being really selective in what you're presenting. We want the poster to be the kind of the epitome of your project, showing off the best part of your work. So it's the end of a nice good amount of effort that you guys have put in. So you want to show that off. Now this is really interesting. People's eyes travel in a certain way when they look at a poster. And so that's something that you might want to do a little bit of research on. But typically within European countries, you'll find that people will read left to right, typically. And you'll be amazed. Sometimes we receive posters where the information is a little bit more haphazard. And while there's nothing wrong with that, because we are encouraging creativity, there are ways to guide the human eye, whether it's through numbers, 1, 2, 3, 4, or letters, A, B, C, D. So there are ways of putting information, around a key image, for example, and guiding somebody's eye in the right way. So think about how you want your poster to be read. Is it left to right? Is it top left downwards, and then over to the middle, upwards, down to the bottom, over to the right, top, down to the bottom? Is your poster going to be landscape? Is it going to be portrait? All of those things might influence the format and the layout of your poster. Arrows are very useful as well. So if you are annotating any images, make use of arrows. Those can be really helpful to you. And have some space. So at the edge of your posters, don't have text that goes right up to the edge of your poster. That's always a kind of graphic design no-no. So give yourself a little bit of space, and whatever that width is, in between chunks of text on your poster, whether it's from left to right or from top to bottom, think of these invisible column widths, and you want those column widths to be generally quite equal, because it then has an aesthetic appeal to make those column widths equal. If you find that one block of text on the far left of your page is very close to the next block of text, and then there's a massive gap, that the human eye generally doesn't tend to like that unless it's by design. So these are little details that we're encouraging you to think a bit like a graphic designer about. And avoid long, detailed sections of text. Summarize. Use bullet points if needed. Use a fairly decent sized font, and avoid essay type copy and pasting from your from documents you may have written internally for your group. Make use of images. That's really important. So there are websites where you can get free images that are royalty free. So we can provide some information on that momentarily. I'll put a couple of suggestions in the chat, but make use of graphics if you need to. Ideally, most of your images should be your own from your CAD models and from some of your analysis. But if you want a nice background image, I'll provide some royalty-free websites where you might get some useful documents from. Let's move on to style. So, yep, keeping it simple, clear and concise is really important. I mentioned background there. There's nothing wrong with having just a plain coloured background. So you don't necessarily need to have an image in the background. So in a moment, I'm going to show you another website for inspiration, just to start to give you an option to explore a more design type website that may inspire some of your work. But there are different ways of communicating posters. Solid black backgrounds can work just as well as backgrounds with a nice image. if it's done in the correct way. So it's all got to be done by design, really. And it does require you to talk about it in your groups. So consider your font sizes. Try not to mix too many different sizes. So typically we recommend 2 or 3. So your headings should be, or your main heading should be quite large. Other headings should be obviously a bit smaller, and underneath those subheadings you should have the smallest text. Having said that, make sure that all of this is readable. So if you're using an 8-point font, it's going to be very difficult to read, so try to avoid that. And maintain a consistent style throughout. So once those decisions are made in terms of your font sizes, stick to them. Those are your design rules that you follow in your poster design. The use of colour is really important as well. There are colours that will clash. So this is where you might want to do a little bit of research in terms of colour harmony. So on a given colour circle, there are colours that inherently look like they are meant to be paired together. So one way of selecting colours is to select opposite ends of a colour wheel. An example that I like to come back to is, for example, blue and yellow tend to be on opposite sides of the colour wheel. And so blue and yellow colour schemes tend to look quite harmonious. There are also other colour schemes that make use of 3 colours. So in your groups, this requires a bit of a discussion as well. So if you're going to use colour, don't make it a kind of diarrhea on a page kind of appearance. You want to be very selective about the types of colour you use, and make that part of your design rules. So if you've identified, say, 3 or 4 key colours, stick to those 3 or 4 key colours. Don't introduce more and more, because it just starts to get visually distracting. And there are colours that clash and don't work together. So colours like red and green, orange and green, we tend to avoid because of they tend to be colours that are difficult to perceive for individuals who are colourblind. So those are things to consider as well. And also having very dark colours next to one another. So if you've got dark text on a dark background, it's very difficult to read. It doesn't take much just to flip the text colour and make it a reversal of the background colour, so that it stands out and it's much more readable. So think about contrast as well. And the final thing that I'm going to point you towards is a really nice website that's called Creative Block. So if I just scroll up to the top, the Creative Block website's got really interesting articles that relate to different design topics. And in a moment, I'll share this link on the VLE, but there's articles like how to design a poster, so 10 pro tips. And it's just really nice to see the examples that they provide. But there's some really good advice there. So that's something for you to read in your own time, folks. And there's some key messages there that could start to form some of the rules that you follow internally within your groups. So for example, mixing your typography, that's something I hadn't quite covered, but that's a nice point. So generally you don't want lots and lots of different fonts, but there's ways of picking 2 fonts that complement one another. So you could use a particular font for headings, but then maybe chunks of concise text, you might use a slightly different font. So not only does it differ by size, but it differs by font as well, and you've got a really nice aesthetic going through your poster. So I'll share this momentarily with you on the VLE, and there's some further articles as well. And I must say the Creative Block website becomes quite addictive very quickly. So I tend to find that I click on these URLs at the bottom of articles, and before I know it, I've lost half an hour on Creative Block website just reading stuff. So it's just a really nice website for you to start making part of your daily routine as engineers to start reviewing. And that's what I was going to cover. I think if I just go back to VLE, I think that's most of the links that are up there already. And as we post more information on the Coursework 4 location, folks, we'll make announcements in class to make you aware of that as well. Ben, is there anything there that you wanted to build on or add to?
No, I think that's good. I've kind of been answering some questions in the chat as we go along, and I guess one that I've answered, but maybe we could just confirm. There was a question about when people should let us know their groups, and I thought we could collect group names in class in 2 weeks, but maybe it's better if people email us or can email us before then. I didn't have a decision there.
That's a good question. Either one works. So perhaps we start collecting them next week loosely and then finalize the following week in class.
Great, I think I agree with that. So I'll put that in the chat as well, just so it's confirmed. Cool. Okay, shall I? Well, I guess let's just see if anyone has anything else that they want to ask about at the moment. You know, I guess just actually one thing to reiterate now is that the deadline for this is after Easter. And there was some question about what's Coursework 3, what's Coursework 4, which I know can be confusing. So Coursework 3 hasn't happened yet, but will be the CAD test, but that'll all be over and done with by week 6. So we want to make sure that you know that, well, first of all, that all the assessment points are spaced out throughout the year. You don't have a crunch coming all at once, but also that, you know, as with Coursework 1, there is quite a lot of expectation about the amount of work you'll be able to put into this, because you've got 10 weeks of class plus the Easter holiday to be kind of thinking about this and developing it. So you won't be able to do it at the last minute.
Ben, sorry. I had a question. So based on the prototype you showed us before, where the one with the cleaning pipe that they used to model, let's say, the shock absorbers and dampers. So the question is, so on the Fusion model, we can actually go into like a more complex design that maybe we wouldn't be able to manufacture at home, but then the prototype just needs to show, let's say, the system even in a simpler way.
Yeah, I think that's a reasonable way of putting it. I mean, how I think of it in my head is, we don't want your prototype to limit what you do in CAD. You know, we don't want you to simplify your CAD so that it becomes something you can build, but we want your prototype to add to what you can do in CAD in a way. So it could just show some parts of it, or show aspects of the function of your rover, but not the whole thing.
Okay, great, thank you.
Okay, CLSU is also putting in the different bits of coursework into the chat, and yeah, that's absolutely crucial, of course. Yeah, question from Manjot. Let's think about this now. A question about the e-portfolios. We're being told that Mahara is coming back up, and it will be back up soon. We're also being told that there's an alternative portfolio option within Teams. So we're finding out more about that too. And then, you know, a final option is that we ask you to put your portfolio together in something like PowerPoint or Illustrator, both of which you can combine images and text. So at the moment, I would recommend you make sure you're still working on your Fusion models and kind of producing things for your portfolio. Make sure you're saving screenshots and saving text somewhere, and then as soon as it's possible to put it into the actual portfolio software, we'll let you know. It doesn't mean the deadline is extended, no. It means we will obviously be, you know, quite often we look at when you're working on certain things in your portfolio. There'll be no expectation that you are uploading things in January or early February to your portfolio, but this hasn't stopped you doing the work. It just stops you combining everything into one document at the end. So I don't think we feel it needs any kind of deadline extension. I mean, also just to be clear, if we were to extend the deadline, that would then mean that it was overlapping with resit exams and then with coursework 4. And actually, I think that would be a worse outcome for everybody. So I'm really very keen to avoid that and to come up with alternative ways for us to assess it instead. Okay, let's move on, and then we can keep coming back. I guess Alessio as well can keep an eye on the chat throughout, and we can come back at the end and we'll have some free time. I remembered one really cool thing that we used to, at the start of this, when we first started looking at the Mars rover, we used to ask people just to come up with all kinds of creative ideas around it. And nobody ever suggested putting a drone on the Mars rover, but that is what NASA have just done. And the NASA rover that's about to land has this helicopter in it. It'll be the first time we've ever done powered flight on, or flight of any kind really, on another planet. So I'm going to put the link to that in the chat. And again, this, I'm afraid it's hard to link this directly into the coursework that we're asking for, but I hope, you know, everybody can see there's all kinds of interesting engineering here. There's a question earlier on in the chat about, you know, gravity is going to be lower on Mars, which is exactly right. Do you need to think about that? I guess the answer is could be interesting. Maybe you do, maybe you don't, but certainly, you know, that's an aspect of the engineering here. But the thing with the Mars helicopter is that the atmosphere is also a lot thinner on Mars, and so it's very, very difficult to design a drone. You know, we've only had really good drones on Earth for maybe 10 years or so, and now we're trying to design them for this very thin atmosphere where you just don't get as much lift because there isn't as much gas to push against. So lots of interesting engineering there. Take a look at the website and see what you think. Okay, I'm going to sort of try and keep this to time as best as I can. But I just wanted to do another CAD example. And again, people can work along. This is something that we produced in class before Christmas. And it was slightly, in one way, looking at McMaster car components and how to insert off-the-shelf components into your CAD models. And one of the things that I thought was interesting when we looked at all of your coursework 1 submissions was people were doing some of this, and that was great to see. And then there were some places where I just wanted to reinforce a few messages. So I'm going to try that now as a demo, and we'll see how it goes. What I'm going to do first, if you think about this as relating to coursework 1, then what we might do is to insert a motor. And lots of people did this. Lots of people had convincing looking small electric motors on their vehicles for coursework 1. I'm going to go with compact DC motors, and then there are dimensions here, and I'm just going to put in a small motor. This fourth one down is about the smallest of them. So that's this one. You'll notice it costs $100, so it wouldn't have worked for coursework 1, but you can buy equivalent DC motors very cheaply that don't quite have the same rigor and function. So I'm not going to worry about the cost for now for this demonstration. And then what we said is you click on the part name, and then you click on the CAD icon to get the CAD details, and then you choose 3D step here and say download. And I'm hoping that that will, if I wait a second, put a motor into my model. And that looks, you know, like a reasonable start. It's about the right size for my model. It's sort of in an okay position. What I'm going to do next is just to locate it a bit more. I'm going to try just turning on the origin of my body there, because I want this motor spindle to be aligned with the center of my body, so I can drive off this motor and then have it centered within that drive system, centered within the vehicle. And then the other thing that I'm going to do is to, sorry, I shouldn't have stopped moving that, so I'm going to right click and say move copy the motor again, because you can see it's got these two flat faces on the sides at the moment, and I want those flat faces to be on the bottom. And if I look from the front, I should be able to confirm that that's worked okay. And then I want to try and align it so it sits on the bed of my the body of my vehicle. I'm going to say that's okay. There's a slight gap there that I can see. If you look closely, you can see that this isn't quite touching on the vehicle. We could probably use the modify align option to get that to sit exactly where we want it to. So if I just turn off the body and ask for this face to be aligned maybe with this face, it'll just get them to sit exactly together. So now that gap that was there is gone. And again, if I look from the top, I hope I'll see that that spindle is aligned with the center of the body. So the reason that I wanted to do this, partly I just wanted to remind you about putting in these McMaster car components, but partly I also wanted to say this is where a lot of people got to in coursework 1. A lot of groups got to here and they said, okay, this is good. We've got a motor and we've got some wheels, and so the motor will drive the wheels, and that's how our vehicle is going to work. And I think we just want to encourage you to maybe take your CAD models a bit further than that, because as this stands, as I've drawn it now, the motor isn't going to drive the wheels at all. I mean, one problem obviously is I don't have a battery yet. I don't want to get too far into the electrical side of things, but a real problem is that the motor is still slightly floating free in space. And the second problem is that the spindle that's going to do some turning isn't actually connected to the wheels. And so I just wanted to look at ways to fix both of those things, and then you know, that will bring a level more rigor into CAD models. Obviously, we've already discussed that in coursework 4, you're not going to be putting a motor onto your vehicle, but nevertheless, you need all these ideas that things have to connect up, and that it's not just enough to say, there will be a suspension system, you have to actually show us exactly what the suspension system is. So the first thing that I'm going to do is to create a new plane offset from that plane, just so it sits somewhere near the middle of the motor, because I'm going to build something to hold my motor down onto the bed of the vehicle. So I'm going to make that maybe -28 or so. That looks reasonably well aligned within the motor. And then I'm going to sketch on that plane. And what I want to do is to bring in the top of this motor. I'm going to project the top of the motor and say OK. And I'm going to project this line here and say OK. And then around those, I'm going to build some kind of a clip, effectively. So let's start here and go up, across, across to there, down, and again, I want to go needs to come down there, and that needs to come down there. That's more like the kind of thing I envisaged, and this line has stopped being vertical, so I'm just going to make it vertical. So what I want to do now, I'm kind of designing this on the fly, but just to show you the kind of thing that you might end up doing. To locate that onto there, like that. Okay, cool. So now if I finish that sketch, what I can do is to extrude out this clip or holder. I'll make it symmetric, so it goes 5 mm in each direction. And I'm going to now turn that particular body into a new component within the main assembly, which I'll call motor clip. And now if I look at the main assembly, I can at least start to see how the motor stays held in place. Then I go back and improve on this. It's a bit ugly at the moment. The best way to do this might be out of sheet metal. I'd like it to be symmetric. And what I need is some kind of a fitting, just to show you perhaps the next step would be if I activate that clip and sketch on this face, I could put in some through holes on here and extrude that all the way down. Cutting only the motor clip through hole. Extrude that to cut. Okay, well, I guess I'll say to object to that face, and then we've got a screw hole that I can feed a screw into to hold that clip down. So The important thing about all of this is we've moved on from just having a motor floating in space to having a motor that's actually fixed down somehow on our vehicle. And then we can improve that design now, and I think it certainly needs some improvement, but at least we've got a physical sense of what's going on. We can do the same thing if I now sketch onto the main body of the vehicle, and if in fact I activate the body so I'm working on it and then sketch on it, I can cut a notch into the body for a drive system like this, finish that sketch, and then extrude that notch as a cut. Cutting only the body itself. I can't see why that's not allowing me to cut the body. Extrude that downwards as a cut. I'm just going to accept this and see what it says. That's fine, that should work okay. Then when I activate the whole assembly again, I have cut the axle, which is not what I wanted to do. So I need to go back to this extrusion and make sure that it isn't cutting the axle and say OK. Better. So now I've left the axle in place, and what I've got is some kind of possibility of connecting my motor up to my axle. Next, I guess I can sketch a new part on that face. And what I'm going to do, select this circle here and say OK, and then use that circle to make a slightly larger circle. Let's say 12 millimeters. Finish that sketch and extrude that in both directions symmetrically, and join it onto the axle and say OK. And now what I've got is something that I can run a belt from the motor directly onto the axle with. So that's what I wanted to be able to do next. So I'm going to finish at this stage by doing that. I guess one more thing I could do actually is to do another sketch, this time projecting out the spindle, saying OK, and drawing a circle on the spindle, maybe quite big. Let's make it 25. And extrude that in 2 directions. So that now, if I run a belt from this additional plate down to here on the axle, I'm starting to get a system in which the motor will actually turn my axle. And to draw that, I'm going to keep it quite simple. I'm going to use the slice plane now, and then project this circle, say OK, and run tangent lines between the two. Make sure I've got tangents at all places they meet. And now they're all locked in place. And then finally, I'm going to use the offset option on that loop. Just make everything else invisible now. I guess I can trim I'll add in these circles, so I've definitely got them. Not able to use them as I want to at the moment. And then I'll trim edges of those. And now I hope I should be able to offset that entire loop, let's say -1 millimeter. Okay. Finish that sketch. Extrude the belt symmetrically 1 millimeter. Let's make it 2 millimeters. And make that a new body. Okay. And now when I turn everything back on and look at it again, what I've got all of a sudden is a motor that's held in place, and I can start to believe that when this motor turns, this axle will actually turn and the vehicle will actually move. I wanted to do that reasonably quickly, just so that everybody could see what kinds of outputs we want to get to here, which is just going from, I know all the bits, and I know that they all have to be in there somewhere, to seeing how things connect up. And that's something you build up throughout your engineering degrees and throughout your engineering life. And I think it's particularly useful to think about this semester because you're also working on machine drives and mechatronics, and some of these kinds of things like belt drive systems will turn up in machine drives and mechatronics. And there it certainly won't be enough just to say the motor drives the wheels. You want to be able to show the motor connected somehow to the wheels and driving. Okay, so that kind of thing is how you might go from a low-level concept design to a fairly high-level concept design. There's a second problem here, that this motor spins very fast, and I don't think I've got the gearing right between the motor and the axles. I think I'm going to be trying to move everything far too fast, and in fact, the motor probably won't have the torque to move at all with this particular gear ratio. But that's okay. Now that I've got started and I've got some of my designs in place, I can think about how to maybe put in a gearbox between the motor and the axle as a kind of secondary unit, and then that will make sure that the motor is driving the axle at the right speed. And just one more thing before I finish by talking about exploded views. I guess first of all, I just want to check that this body one should become a new component, which is the belt. In fact, one more useful thing, then I can turn on this idea of component color cycle toggling, and I can see all my different components clearly and where they are. So that's under the inspect menu, and that can be pretty useful. In fact, turning it on really makes it clearer how this drive system works, I think. And then one other thing I just wanted to show you while I'm talking about gearboxes is that under Tools, Add-ins, Scripts and Add-ins, there's actually a built-in bit of Fusion which will help you design gears. I think you'll come onto this within machine drives and mechatronics, but I just wanted to show you that you can design a gear wheel using that built-in script. And if I were to hit OK, that would then be available in my model. And I'd be able to start building up a gearbox using these gears sized appropriately and some axles held in place on the body of my vehicle. OK, let's finish just by thinking about how to make an exploded view of this. I know Alessio and I were having a chat earlier, and I know that you've covered all of this in design and practice last year. So in a way, this is revision, and we saw some about 4 good examples of exploded views across coursework 1. So clearly, some people went back and thought about design and practice, and that was great to see. But for anyone who's forgotten, it can be useful just to keep on having reminders of these things. So to make exploded views in Fusion, what you end up doing is actually going into the animation environment. So usually we've been in the design environment up here in the top left. We've done some generative design, we've looked at renders, we've looked at some simulation. Now we're going to talk about the animation options. And you get this timeline where you can make an animation with different things happening at different times. Whatever I do now will be located at 1 second in the animation, and then I can drag this slider and have something else that happens, say, at 2.7 seconds. For now, I don't want to do an animation, but what I do want to do is an exploded view. And you'll see we've got in the model tree a list of all our components, and I can choose the whole vehicle bed. The first option is this one called Auto Explode. And if I just click on that now, it takes a little bit of time, but the software will use some kind of artificial intelligence to try to guess what a good exploded view might look like here. And that's what it's come up with, which maybe isn't quite what we would have come up with. Hard to, maybe it is, maybe it's not. But I think we might try something different. So I'm going to Control Z, undo that, and then I'm going to start doing some manual transforms. So I can click, for example, first of all on the wheels and say transform components and drag them out. I'll drag all the wheels 150 millimeters out from the body. And then I might say, okay, let's have a look at the bearings. We'll drag them 100 millimeters so that we can see them completely separately from the wheels. But it's kind of clear as well that the bearings are going to fit into the wheels, fit inside the wheels and operate with them, because we still kept them sharing an axis, coaxial, I guess you could say. So that looks pretty good. I'm happy enough with that. I think it's going to be clearest if I keep the main body where it is. I noticed I didn't do a good enough job separating out the motor clip and the body, so they've become one component. I'd have to go back into the model tree and fix that, and I'll do that later. But it'll work fine for now. The next thing, though, that I'll move are these axles. And if I'm keeping the body where it is, maybe I just want to lift the axles up a bit just to show where they sit relative to the body. So that's nice and clear. I'll move the motor out as well so that we can see that motor nice and clearly. And then I'll move the belt. And I'll have the belt shown near the motor, like so. That's kind of okay. You can spend a long time playing with these things. Certainly I'd want to make this motor clip a separate component. I think I just need to go back and fix that, and then I could show that that would lift off upwards. And part of the idea here is that this exploded view should give people a sense of how they're going to manufacture. So the only thing I don't like there is that, first of all, these axles, it isn't quite clear from the exploded view where the axles go. I might almost just not bother to transform them. There's also, because I changed the design of one axle and I'd copied and pasted, that's now affected the design of the other axle, and we might have to think about how to fix that too. So you need to always, you know, I guess a design process is to always be going back and looking, saying, did I get that right? Do I need to just adjust this? Do I need to look again at any part of my design? But for now, I'm going to say that's okay because I'm reasonably happy with it. Try and find an angle where everything's pretty clear. And then I'm going to say, okay, that's my exploded view that I'm going with. And then once I've got the exploded view all lined up as I want it to by transforming the components, I can either take a screenshot right now, so just get an image of that exploded view as it is, or I can go up to File here, and then I want to say New Drawing from Animation. I might just save everything first, so that I know I'm using the latest version. New Drawing from Animation. For now, I'll just accept all these defaults, but again, you might want to look at different drawing sizes, for example. Takes a second just to put it all together. And then I can lay this into a drawing like so. I think it looks quite reasonable there. I might even, rather than have it be visible edges when I complete it, just to show you this, if I say OK, I get visible edges, which looks like that. But perhaps, in fact, I really just want to keep that shaded view, which may be even clearer to anyone who's using it. So that's the kind of option I can change within the drawing. And then maybe the next thing I do is to put in a parts list, which I can slide in here. And again, a few people, a few groups in coursework 1 used this really nicely and were able to show very clearly how their design would all fit together based on this kind of drawing of an exploded view. The other thing that should happen that I would need to go back and address is that this should make it very clear how I'm going to make everything. So the belt here says it's made out of steel. I need to go back to my model and change that to be rubber. I think now I do need to just tune these axles. Perhaps I could even, rather than have made this this additional ring on the axle, made it join the existing body, I could have made a new component. And so the axle slides through an extra fitting there with an interference fit. And that fitting is for the belt to drive against. So I could have done these axles differently to make them easier to manufacture. And now that I see this drawing, I really see that quite clearly. I've got much more lathe work to do with these fiddly extra bits in the middle than I would if I just had a clean, smooth bar. And I can see here, for example, how I can make the wheels very easily on a lathe from nylon. So that's the kind of way we'd like you to move towards thinking about using CAD for some of coursework 4, really making sure that the connections and the operation is all shown clearly, and that if we were to build your CAD model exactly as it's shown in CAD, things wouldn't fall off it, and it would work exactly as you imagine. And then secondly, that if you gave us this exploded view or a useful view of the parts in your assembly, that we could start to see very quickly how they would all be manufactured. And those are the things that I think we'll keep trying to build up a bit throughout this semester. And we'll talk more as well about manufacturing and workshops and things like that too. Okay, that has taken us to 10 to 7. So I'm keen now just to open it up to questions. I saw a few things coming through in the chat as I was working there.
There was an interesting question just now, Ben. It was about students who wish to create an animation and how they could submit that, which is a lovely way of thinking, Manjur. Thanks for asking that. There's a number of ways we can do that. I've suggested a couple. We can also potentially set up a folder on Teams for your next group, and you can upload videos there. So that's another option. So there's a couple of things suggested in my reply, but if you want to do that, folks, that's one of those things that we would encourage you to think about. And don't let things like file size put you off in any way. If you've done the work, we'd love to see it. So we'll figure out a way for you to get that that file to us.
Yeah, one thing that I've seen a couple of groups do that's worked very well with posters in particular is to put a QR code onto their poster, so you can use a QR code, you know, like those the barcode, two-dimensional barcodes. You can use those to link to any website, and so then people can scan your poster with their phone, and immediately they'll get taken to the website where you're showing the animation of it. And you know, that can seem that can be a very professional way to do things if you do it in a kind of neat way.
That's a really neat way, isn't it? I'd forgotten about that. Yeah. There's free QR code generators online, class. So yeah, if you put a QR code on your poster, Manjur, that could be a really nice way for us to get to your animation. Any questions, folks?
Sir, in this assignment, we have been asked to redesign a Mars rover. Assuming that several models have been designed in history, do we have a specific reference we are redesigning, or we are coming with a new mod?
So, you were a bit faint there, Safas, but I think, were you asking, is the one, out of all the different Mars rovers that exist, is the one that we're suggesting you redesign? Was that the question?
Very correct, spot on the point. That's the question, sir.
Yeah. Okay, great. So I think the answer is the JPL model Mars rover, the one that's shown on the link on the VLE, is probably the one that we'd like you to most start from, at least. So it doesn't have to be exactly that one, but they've made this, it's a really, you know, we recommend everyone goes and has a look at the website we've linked from the VLE that's run by NASA, because they've made this really nice resource about how you can build your own Mars rover. And the one they have designed is like, I don't know, 70 centimeters long or something like that. It costs about $3,000 if you add up all the parts and all the electronics and everything. So, you know, maybe we could build one as a whole class would be another way to do this exercise. But what we want you to do is to take that $3,000 version and then shrink it down again, forget about the electronics, and give us the $20 version, the £20 version. You know, that might be one way you could think about this task. And so I think starting from that JPL version is the way to do it.
Oh, thank you, sir.
Good. I guess, you know, we've covered quite a lot here, and I know we're starting to accelerate a bit in kind of, rather than go through the CAD in a very stepwise way, we're sort of now getting into showing just how we would do it if we were doing the CAD ourselves. So I guess it's useful for us to get a feeling of where people are with CAD, and that probably leads us into next week, when we'll do a practice version of the CAD test. So when you come to class next week, please be ready one way or another to use Fusion live in class. We'll provide the test. We'll give everyone the appropriate amount of time, and you'll be able to see at that stage where you are kind of relative to where you need to be for the CAD test. And then after that, we'll give tutorials that are available on YouTube to make sure you can catch up if anyone needs to catch up, get up to speed, and then we'll have the CAD test 2 weeks later. Question from Zishan in the chat. That's not quite right what you said. I think you're right that you don't want to focus on any electronic parts. You know, it may be, I think we're trying to say there's no one way to approach this. It may be that some groups really have a passion for some kind of driven suspension with electronic actuators or motors. We don't want to stop you doing that. But yeah, probably no need to focus on the electronics. The mechanical parts, you need to think about the wheels, the suspension, the possibility of steering, I think, and the way that you support the mobile phone. Those seem to me to be the main mechanical aspects of this. And then an almost impossible philosophical question from Mustafa: is this week 2 or week 3? I think we're gonna say this is week 2, because it's the second week of teaching we've done. Although obviously, before we moved all the semester 1 assessments, this would have lined up with week 3. But this is week 2. Thanks a lot.
I may have caused confusion there then, Ben. In the chat I said test was in week 6.
Okay. Which will make this week 3. Nobody knows what week it is.
I'm so sorry.
Maybe it might be me who's wrong. I think what we can definitely say is the practice test is in 1 week and the real test is in 3 weeks. And then how we label that is up for grabs.
Okay. So there were, yeah, a couple of weeks of practice exercises, mock test, then another kind of revision type session, and then the test after that. Is that correct? Yeah. Okay.
And the exam will be in this slot. So, you know, in a normal year, and I look forward to the day I stop saying that. In a normal year, you would all be in T806. You'd come to class as normal, just like your design and practice CAD tests in first year would have been. You all sit down at the computer, load up Fusion. We say start now. You work through it, and then we tell you to stop an hour later, probably. So that's going to be the kind of format. Okay, that's 7 o'clock on my computer. So I think we'll start winding things down. Alessio and I will stick around for a couple of minutes, just in case anyone wants to add in any more questions. But otherwise, thank you for today. It's been another really good class. Lots of good questions in the chat as well. And I think the things to be doing are just making sure that you're happy with CAD. I know a couple of people have sent us emails about some very specific problems with using Fusion. and we're going to work through those with you. But we hope nearly everyone at the moment is able to do some CAD practice, and that's a good thing to be doing. And then just starting the ideation and creativity processes around coursework 4 and coming up with, you know, at the moment, maybe some out of the box suspension designs or ideas, and then we'll kind of guide you back over the semester towards traditional suspension design, and you can pull all of that together and come up with something really interesting. Question, how long is the exam and what time? So the exam the previous year's exams have always been an hour long, and I think unless anything changes, we'll stick to that. And it'll probably take place at about somewhere between 5:15 and 5:30, so that everyone's got time to come into the session, get all of the information, set themselves up, start the test, and then complete it within the class. But as long as you come to class at 5 o'clock, we'll let you know all the details. Question about page or word limit for coursework 4. Good time just to clarify, there won't be a report for coursework 4. If you look at the requested outputs, it's a poster and a prototype and a conversation with us, kind of like a team review with us. Maybe, and a copy of your CAD model. Those are the things you'll be submitting.
Could I ask a quick question about the portfolio? Yes. In regards to all the different models that we're making, I know y'all said that we can like either search on YouTube or go on different like other things and make models from them, kind of like helping us out and guide us. But how many like unique models are you expecting in our portfolios? Like if I look at something in the real world and try to CAD it.
Was that how many models, Floyd?
Yeah, well, at least enough to like make the portfolio decent.
Yeah. I think a good answer to that is just to go and have a look specifically at the previous portfolio examples that we've put on Moodle. I know it's been ages since Moodle went down, and so this is a good time to do a reminder that there are 4 examples of other people's portfolios from last year up there already. And those are all, you know, strong first-class portfolios. So I would say if you're producing the kind of quality and quantity of those portfolios, you're up in the strong first-class kind of outputs.
Okay, but just if you like went on YouTube, but you just have to make sure you reference the YouTube tutorial you were looking at if you were making like a maybe like a part model.
Yeah, exactly. That's the way to do it. Just say, I did this tutorial, I made this part model. You know, here's 3 different images of it, and here's why it was interesting to me. And then that kind of thing is fantastic for your portfolio. Okay. And I mean, you know, we've broken it up as a suggestion into 8 different pages. And I guess maybe you might think you want 5 or 6 things on each of the pages. You'll probably have much more part modeling than some other things, just because that's often where things start from. Yeah. So you might have 20 part models, 4 or 5 sheet metal examples, and that might just be absolutely great. There's no one size fits all, but I do think the previous year's portfolios show you certainly what some of the very good students were doing last year.
Okay, that's all. Thank you.
I'm going to stop the recording now as well.